about limit of a function and how to use this limit to find something we call it asymptotes, right? If you have a function, we have some example of a function. We have a linear function, This linear function is exactly the function of line, or the linear function is exactly like line equation. So this y will be in the y coordinate. We call it the function of x equal to mx plus c. This is what we call it linear function. So in the x-axis, we have the values of x. In y-axis, we have the function of x. So the linear function could be like that. Fm is positive, yes, and could be like that. Fm is negative, right? This is a linear function. Also, we have the quadratic function. Is exactly like the quadratic equation. Yes, y equal to ax squared plus bx plus c. Y, as I said, is exactly like f of x. This is when you graph it in the xy coordinates or rectangular coordinates. You will have a parabola like that. If a positive or negative.
Positive, doctor.
Positive.
It's upside.
Yep. And if you have it like that, sorry.
It will be negative.
Yes, A is negative, A is positive over here, right? So this one controlling the turning point. This is, they call it the turning point. And this one also turning point, but in this case, this turning point is a local minimum. And this is a turning point. In this case, it is a maximum. Okay. This is a quadratic function. Today we are going to talk about a special one. We call it rational function. From the name rational, it means you have fraction, so it have numerator and denominator. So how you can write down your function? Your function f of x will be as a fraction or rational, because you have the name is rational function. So what? So you have a call the numerator p of x and call the denominator q of x. Okay, this rational function having a big problem. Where is the big problem? This one. Yes, it has a big problem. F q of x shouldn't be 0. If it is 0, you will have a big problem with this one. Right. What else? Yes, I have also a big problem when both of them 0 over 0. This is undefined value. Let's start with this one, right? Okay. If you have, for example, f of x equal to 1 over x, right? And you would like to know the behavior of the function when x tends to infinity. So what? You are going to call this one limit when x tends to positive infinity for 1 over x. This is to show you what is the behavior of 1 over x when x becoming so big, right? Okay. just to show you what's going on with this one, let's using Excel. If you have here X, and here you have Y, which is equal to f of X, and I got my function, I call it 1 over X, okay? And I would like to know what is the behavior of this function when X is becoming bigger and bigger and bigger. I start with 1 and then make it 10 and make it 100, sorry, and make it 100 and make it 1000, make it 10,000, make it 100,000, make it 1 million. Yeah, and you can go ahead. I would like to find the value at X equal to 1. So how to do it by Excel? You press equal and then 1 over, and you click in the value here and press enter. So it gives you the value of this one. No need to do the same for the other things. Coming to the bold corner, this one, make the plus sign coming to here and drag it. Yes. So what's going on? 1, 0.1, 0.01 is becoming very close to what? If I'm carrying on, this one will goes to what? But at end up with what? Guys, this one will goes to what? To 0, right? Okay. So
0 دكتور.
okay. So if I would like to write this one, this is exactly, practically I know this one will be 1 over infinity, so it will be 0. Okay. And when I'm using Excel, I explain to you what does it mean, this one. This one, it doesn't mean X equal to infinity. Nothing. Nobody knows what is infinity is, right? So you just saying X tends to, this is, they call it tends to. In Arabic, they call it ta'ul ila, tends to. Okay. We know this one is going to 0, right? Fine. Okay. I said just a minute ago, I said I will have a problem with the rational function, sorry, with the rational function when I have the numerator equal to 0. The denominator, sorry, equal to 0. So I would like to see the behavior of the function very close to 0. How I can write down this one? Yes, I write this one by limit of x tends to 0 for my function 1 over x. Let's go for Excel and taking values very close to 0, right? Okay. Now, very close to 0, if I take 0.1 and then 0.01, 0.001, 1 out of the 1,000, 1 out of 10,000, and 1 out of 100,000, and 1 out of million. Okay. Now, if I would like to calculate the value of the function 1 over x at these values, I press equal, and then 1 over x. I would like to have it for this value, so I press on this one, press enter. I will have this one. No need to do it. For the rest, you just drag the bold corner. Yes, so the value is going to be increasing, and if I go more, I will becoming very huge number, right? This is what they call it infinity. This infinity has its symbols. This infinity. Oh, I don't know how. Yes, it is here, right? Okay. So I can say this is 1 over 0 can be written as what? Infinity, right? So what is the point of the limit? The point of a limit determine the behavior of the function at x tends to infinity. This is what does it mean, right? But this one determine what? Determine the behavior of the function at x tends to 0, right? Okay. What about if x tends to minus infinity? It will be 0 as well, right? So this one similar to if x tends to minus infinity, 1 over x will goes to 0 as well, right? Okay, that's fine. Now I understand what does it mean, the limit of the function at x tends to infinity. This is the meaning of this one. Let's graph this one to see what is the point of having the limit. I'm just asking you, graph the function f of x equal to 1 of x using limit when x tends to positive or negative infinity of 1 over x, you already get it 0, and limit when x tends to 0 for 1 over x is infinity. How I can use this one, these two, to graph the function? Let's go and have x-axis and y-axis. And I know when x increasing and going to positive infinity over here, so the function is 0, right? But when x is smaller, start from 1, it will be 1, right? If it is 2, it will be half, right? So my function will be coming down until going very close to x-axis, right? This is my function y equal to f of x equal to 1 over x when x going to positive infinity. What about the negative side? This negative side of x, when x also going to negative, it will be 0 as well, right? But when x very close to 0, it is infinity, right? Okay. So what is the graph? Yes, if x is negative, y equal to 1 of x. If x is negative, y is also negative, right? So you cannot graph it in the second quadrant. Do you remember the first quadrant and the second quadrant and the third quadrant and the fourth quadrant? Here, x and y are positive. Here, x negative and y positive. Here, x negative, sorry, and y also negative. In this fourth quadrant, x positive and y negative. So y equal to 1 of x, if x is negative, also y is negative. So my function will be in the third quadrant, right? So yes, it will be like that. Okay. Now, what I call this line, x-axis, where my function will be very close to it when it goes to infinity and when it goes to minus infinity. What I'm going to say about this 0, where the function will never connect in this point, right? Okay. Now we call it the continuity, or we call it the continuity of f of x at x equal to a, we say f of x is continuous if what? The first condition, f at x equal to a is defined. It means a value, you know it, right? The second thing, the limit when x tends to a from the right equal to the limit when x tends to a from the left, okay? And then I will link these two together to the third one. F of x equal to, sorry, at x equal to a is equal to the limit of x tends to a, because if the right limit equal to the left limit, there is a limit at this point. What does it mean, left limit and right limit? Let's go for our 1x, 1 over x. If I goes around 0, so around 0, I come to the 0 from the right, okay? So this is, I come from the 0 from the right. So yes, this is, I can call it the limit when x tends to 0 from the right. What about the left? The left, I should have x negative, right? So I will take negative what? Say negative 0.001 and negative 0.000. I will be smaller. Remember, when you have a negative value, it will be to the left. The smaller negative value will be to the left, to the 0, more than the bigger one. Okay. And that goes for minus 0.001 and minus 0.00. Now let's have the value of this one. So equal to 1 over x and the placenta. Okay. So the numbers are going to be smaller, right? It's going to be what? Smaller. So if you go further than this one, so 0.1, okay. Yes, smaller. What's yes, no, I cannot get it because I have to 0, so yeah, okay. So look at this one. When you go to the left and right, when you go to the left, you are going to be bigger, right? You are going to be increasing, right? Catch it? Okay. So let's go for this one and graph this one. Sorry. If you would like to graph 1 over x without graphing the table, just f of x equal to 1 over x. This one. This point, yeah. When you come to the from the left to the 0, okay, you are going to be very big y in the negative side. But when you come from the right to the 0, you are going to have a very big values of y, but positive, right? So how I can write down this one? Yes, I can say f of x equal to 1 over x has what? Has a limit for x tends to 0 from the right side will be positive infinity. And it has, yes, limit when x tends to 0 from the left side, it will be negative infinity. These two must be equal, otherwise it will not be continuous, right? So this one is not equal to this one. So what? So f of x, which is 1 over x, is not continuous. Is not continuous. Graphically, you say not continuous, it means they are not connected. It is not one piece. This is two pieces now. And this is a gap here, right? There is what? There is a gap here. Okay. Now, let's go for another one. So we know how, because this one is not equal to this one, the limit when x tends to 0 for 1 over x doesn't exist. Doesn't exist. Mathematically, they write it like this one. Doesn't exist. If you don't like to write English, you can write this notation. So if the limit doesn't exist, your function is what? Your function is not continuous. So the right limit is not equal to the left limit. So the limit, it doesn't exist. So the function is not continuous. Up to what? Up to this definition of the continuity of any function. So to check the continuity, you have to find the right limit, left limit, if they are equal, and the value of the function is defined and equal to this limit. So the function will be continuous. Otherwise, it will not be continuous. So this function has no limit. The limit doesn't exist at x equal to 0, so is not continuous at x equal to 0, right? Let's have another example. The function f of x equal to 1 over x minus 3. Okay. This has a limit when x tends to 3 from the right equal to what? Can you do it by Excel and check the value? And the other limit from the left let's go for this function from right and left and find the value and check. Okay. If I have x and my function y equal to f of x equal to 1 over, when you have something more than one piece, you have to open bracket for the denominator, x minus 3. Okay. Now, I would like to go from the 3 to the right. So I'm coming from 4 to the 3. This is what does it mean from the right. So I would be very close to the 3. So if I have 3.1 and coming closer to this one, 3.0.01, 3.001, 3.0001. This is what does it mean? You coming from the right side to the 3 to be very close to the 3. Okay, and 3.000. Let's have the value of this function, 1 over what? Open bracket for x minus 3. Close the bracket, press enter. Now, no need to do the same thing, you just have it. So your value is going to be what? Increasing or decreasing? It's increasing and going to very big number, right? So this one will goes to infinity. Fine. Okay. So this is, I can say, when I'm coming from the right, the values are going to positive big numbers. So this will be positive infinity, right? Let's do this one from the left to the 3. From the left to the 3, it means what? I'm coming from 2 to 3. It means this is how I can coming from the left. So I'm coming from the two sides. So 2.99, say 2.9, 2.99. 2.999. This is how to coming very close to the 3 from the left. The left to the 3 is 2. So you're coming from the left, you're very close to the 3, it will be 29, 299, 2. That's more than enough. I press equal. What is the function? 1 over, I have to open bracket because I have this value minus what? Minus 3. Close the bracket, press enter. I have this value coming from the bold corner, drag it. So yes, the values are getting to be decreasing because it's going to minus infinity, right? How I can write down this one? Yes, I can say this is going for a so big number, but negative. This is what does it mean, negative infinity. So this one is not equal to this one. So f of x equal to 1 over x minus 3 is not continuous. Okay. This right limit is not equal to left limit because the limit doesn't exist. The limit when x tends to 3 for 1 over x minus 3 does not exist. Okay, this is around 3. What about the infinity for the same function? Limit when x tends to positive infinity for the same function 1 over x minus 3, it will goes to 1 over infinity will be 0, and the other limit for infinity, negative infinity, for the same function x minus 3, it will be also 0, right? Very good. What does it mean this one? What does it mean this one? This is the behavior to the right to the x equal to 3. This is the value, the behavior around to the left to the 3. Okay. How I can use this one to graph my function? As simple as that. You have x-axis and you have y-axis, and you have a problem exactly at this 3. Okay. So at x equal to 3, what is the function x equal to 3 represent what? A vertical line. This is a vertical line. A vertical line. How to graph a vertical line? This is a vertical line. Sorry. I'm trying to graph it. Okay. Now, problem. I'll change this one into 3. So this is a vertical line, x equal to 3. Now I know the limit of the function at from the 3 from the right is positive infinity, and I know, let's do it from the left, for 1 over x minus 3 negative infinity, and the limit when x tends to 3 from the right for 1 is negative infinity, okay, a positive infinity, sorry. And I know the limit when x equal to 3, x equal to 3 for 1 over x minus 3 doesn't exist, right? Does not exist. This I know this does not exist. Does not exist, it means this function is not continuous, right? At x equal to 3. So at 3, you split your function into 2 pieces, right? Okay. The first piece, I will go to this side. When I'm coming to the right to this line, I have x bigger than 3. When I have x bigger than 3, 1 of x minus 3 will be positive or negative? It will be positive, right? If I coming to the left of this one, x less than 3, my function will be what? It will be less than 0, right? So how I can graph it? Your function is positive. Your function is positive, it means you have to graph it above the x-axis, right? So your function will be like that. To the left side is negative, so you have to graph it down x-axis. Okay. This is how to graph this function, this value x equal to 3 coming from x minus 3 equal to 0. So x equal to 0, 3. This is how to find, this is they call it the vertical line, the vertical asymptote, sorry. The vertical asymptote. So how to find the vertical asymptote without thinking about the right limit or left limit? You take the denominator and put it equal to 0 under one condition. The degree of the numerator must be less than the degree of the denominator, right? This is how to find the limit, right limit, left limit, and the limit at infinity, and how to use it to find the vertical asymptote. And this is x, the value, the limit at x tends to infinity, limit when x tends to positive or negative infinity for 1 over x minus 3 will be 0. So y equal to 0 is the x-axis, right? Y equal to 0 is the x-axis. This is y equal to 0. This value of y equal to the limit at x to positive infinity, they call it the horizontal asymptote. The horizontal asymptote. Okay. Now, let's go for some exercises and check how to find the vertical asymptotes for some functions, right? Let's go how to solve this one together. He's asking you to have the limit This is exercise number 41. Limit when x tends to 2 for the function x to the power 4 minus 16 over x minus 2. Okay. If you substitute as you used to do, right, you will have 2 to the power 4 minus 16 over 2 minus 2. So you end up with what? 16 minus 16, because 2 to the power 4 is 16 over 2 minus 2. This is 0 over 0. As I said in the beginning, this is undefined. So your function is undefined at x equal to 2. So when you graph it, you guarantee at x equal to 2, you have a vertical asymptote. And your function will be to the right and the left to this one, right? And it will not be continuous. Fine. How to find the limit if I have this one? I have to factorize the numerator. So forget about this one now, because I cannot accept the undefined value. So what you are going to do, you just have the limit when x tends to 2. How to factorize this one? X squared minus 4 times x squared plus 4, over x minus 2. You still have this one to factorize. So limit when x tends to 2. So x minus 2, x plus 2, and x squared plus 4 over x minus 2. I'm happy when I have cancel out these two together, because once I cancel out this one, I get rid of the undefined value. So I end up with x plus 2, x squared plus 4 over 1, right? Now if I substitute, I have 2 plus 2 times 2 squared plus 4 over 1. So you end up with what? 4 times 4 plus 4. Okay, so what do you have?
32.
32. So this is defined value, right? So this is the limit, how to find the limit for this one. Okay, let's go for the next one. 42. How to find the limit when x tends to negative infinity for the function x cubed minus x squared minus 5x minus 3 over x plus 1 square. Also, if I am substituting what I have here, I substitute by minus 1, so I have minus 1 cube minus 1 square minus 5 times minus 1 minus 3 over minus 1 plus 1 square. So I have up here, I have this minus 1, I have minus 2 plus 5 minus 3 over minus 1 plus 1 square. So I have 0 over 0. This is undefined value. So how I can get rid of it? I can factorize. How I can factorize this one? Can you factorize? Help me to factorize this one. X cubed minus x squared minus 5x minus 3. I'm supposed to have x plus 1 square with this one, right? But how I can do it? This is the main point. How we can get this one? Guys? Okay, no problem. If I don't know how to do this one, and I know what does it mean x1, x plus 1 square, it means x squared plus 2x plus 1, right? Okay, so I know this is a division. This one, exactly a division, right? So if you know how to make the long division of x cubed minus x squared minus 5x minus 3, and you divide it by x plus 1 squared, so you have to factorize it to be easy for you. How to make the long division? You divide this one by this one, so you have what? X cubed over x squared is what? Is x, and then you multiply it here, so you have x cubed plus 2x squared plus x, and then you subtract, or they call it, you change the sign. If you don't like to subtract, you just add after changing the sign. So this one will be cancelled out, this one. You have minus 2x squared and a minus, so you have minus 3x squared. And you have minus x, and you have already minus 5x, so you have minus 6x, and you get the minus 3 then. Yes, you still have the degree is equal to this one, so you can make more division. So you get this one over this one, so it will be minus 3. If you multiply by minus 3, you will have minus 3x squared minus 6x minus 3. So this one, all of this one cancels. So this is the result. So this one is exactly like what? Like the limit when x tends to negative infinity. This fraction is exactly the long division, right? So the result is exactly like x minus 3. So if you substitute by minus 1, now you get rid of the undefined value, so the limit will be minus 4. Easy? If you would like me to repeat again, I will repeat again. Okay. I repeat it?
Yes, doctor.
Okay, sure. Okay. From scratch, is asking you to find the limit when x tends to minus 1 for the function x cubed, this is 42, x cubed minus x squared minus 5x minus 3 over x plus 1 squared. If you substitute straightforward, it will be what? Minus 1 cube minus 1 square minus 5 minus 1. You replace x by minus 1, minus 3 over minus 1 plus 1 square. So you end up with what? Here, this is minus 1 because the power is odd, so the negative stay as it is, and 1 cube is 1. And minus 1 to the power 2, 2 is even, so the negative will disappear, but I have minus outside, so it will be minus 1. Minus 5 times minus 1, minus will be positive, 5, minus 3, and minus 1 plus 1 is 0 square. Minus 1 minus 1 minus 3, it will be minus 5, and I have positive 5. So I end up with 0 over 0. So this is undefined value. So I have to factorize and cancel out something from here to get rid of the 0 in the denominator. I have no problem if I have 0 in the numerator, but I have a problem if I have the 0 in the denominator, right? So this is exactly like a fraction. So the numerator divided by the denominator. How I can divide this one? How I can divide this one? Using the long division. So I know x cubed minus x squared minus 5x minus 3 over x plus 1 square. Exactly like what? Like what I'm going to do here. I know this is exactly like x cubed minus x squared minus 5x minus 3 over x plus 1 squared, the square of x plus 2 times x times 1, so 2x plus 1. This is how to factorize the complete square. You square the first one, 2 times the first one, second one, plus the second one square. Okay, so this is exactly like what? Like a long division. This is exactly like what? A long division. Long division of what? Of the numerator, x cubed minus x squared minus 5x minus 3, divided by what? By the denominator, which x plus 1 squared, which is x squared plus 2x plus 1. How I can divide the long division? I take the first one here, divided by the first one. X cubed divided by x squared will be x. And then I multiply this one here and here and here. X times x squared will be x cubed. X times 2x is 2x squared. X times 1 is x. Now you subtract, you make subtraction, or you change the sign and add, it's up to you. Now this one will be cancelled with this one positive and the other one negative. Minus x squared and minus 2x squared will be minus 3x squared. Minus 5x minus x will be minus 6x, and I'll get this minus 3 down. Now I can divide it, yes, because I have this one has the same degree at the divisor. So minus 3x squared over x squared will be minus 3, sorry. Now I will do the same as I did here. So I multiply by the 3 terms. Minus 3 times x squared, minus 3x squared. Minus 3 times 2x is minus 6x. Minus 3 times 1 is minus 3. Now I subtract or change the sign and add. All of these things will be cancelled out. So I have 0. So the result of the division is x minus 3. So this one divided by this one will equal to what? Limit when x tends to minus 1 of x minus 3. Now, if I substitute by minus 1, I have no problem because I don't have any defined value. So the limit will be minus 4. Is it fine now? Okay.
Yes, doctor.
Let's go for the next one. Number 43. If you are looking for the limit when x tends to 0 for, let's go for 44, but no need for, this is by mistake, it's making cube, leave it. You have x squared minus 9 over root square of x squared plus 7 minus 4. Again, you substitute first. When you substitute by x equal to 0, you have 0 minus 9 over root square 7 minus 4. Oh, sorry, I wrote it. I wrote by mistake. I wrote it 0. It's supposed to be 1, right? This is 1, not 0. Okay. Now if I substitute by x equal to 1, so I have 1 minus 9, right?
Doctor, it's not 1, 3 in the question.
Oh, sorry, it's 3. I've done. As my eyes I cannot see. Okay, 3, right? So I have 3 square minus 9 over 3 square plus 7 under the root square. Okay, minus 4. So you end up with 9 minus 9, and you end up here with 9 plus 7 minus 4. So you end up with 0 over root square of 16 minus 4. So it will be 0 over 4 minus 4. So it will be 0 over 0. Undefined value. Undefined value. So what I'm supposed to do? Last time I factorize. Okay, I factorize and I get rid of something making 0 in the first one, like this. And here I don't know how to factorize the numerator, so I got it as a long division, which is a normal. A fraction is a long division. Okay. Now, what am I supposed to do with this one? I cannot factorize. Also, I cannot make a long division because I root square. Yes, I have to multiply by this, the conjugate of this one. So multiply by the conjugate. What does it mean, the conjugate of root square of x squared plus 7 minus 4? The conjugate is just changing the sign between the root square and the number. So you make it positive instead of negative. Okay. Now let's do and multiply by the conjugate of this one. So what? So the limit when x tends to 3 for what? For x squared minus 9 over root square of x squared plus 7 minus 4. So you multiply the numerator and the denominator by the conjugate, which is x squared plus 7 plus 4 over root square of x squared plus 7 plus 4. What is the point of multiplying by the conjugate? As I told you, just to change the sign between the root and the number. So yes, this is the square difference. In Arabic, they call it فرق بين مربعين. So this is a square difference. So what does it mean, square difference? I will explain it to you. The square difference x squared minus y squared, you factorize it like this: x minus y, x plus y. Okay, this is the point. So what? So when you multiply by this one, so you have to square this one to get rid of the square, and minus, and you have to square this one. So the limit will be what? Yes, the limit when x tends to 3, 4, I have x squared minus 9 over root square of x squared plus 7 minus 4, and then multiply by the conjugate, which is x squared plus 7 plus 4 over root square of x squared plus 7 plus 4. The point of multiplying by the conjugate, again, I'm telling you, as to have the square difference. So the square difference make what? Make this one root square x squared plus 7 square minus 4 square. Okay, and I will still have x squared minus sign over here, and limit when x tends to 3. Now let's square this. Yes, the square and the root square cancel each other, right? So I have x squared plus 7 minus 4 squared is 16. I forget. Yeah, I multiply this one and I forget the one up here. Okay. Now, what do you have? Limit when x tends to 3. 7 minus 16 is what? Minus 9, right? So x squared minus 1. And I have here x squared minus 9 times root square of x squared plus 7 plus 4. Okay. I can cancel out this one with this one now, and I can substitute without any suspicious to have undefined value. X equal to 3, so I have 3 squared plus 7 plus 4, so you have 16 plus 4, so you have 8. Okay. This is all what you need to know today, and we'll complete this one, inshallah, next lecture. I don't like to make too much information till now, and see you next lecture and campus, inshallah.